Hello, and welcome to a special JMR event. I would like to introduce our host, Editor-in-Chief of Journal of Materials Research, Gary L. Messing. Dr. Messing, if you would kick things off, we will begin.
Thank you, Ellen. I'm joined this morning by Dr. Ryan Combs, Assistant Professor of Physics at Auburn University. Ryan, thank you for joining me. And also thank you to the audience members joining from your home screen or directly from Boston. Before we get started with the prize award, let me first announce the call for papers for the 8th Early Career Scholars issue of the Journal of Materials Research. The ECS issue publishes papers concerned with advanced materials research that we normally would see presented at the MRS meetings. The ECS is a unique opportunity for young researchers to be highlighted early on in their career. The issue is published as an open access basis so that all participants can gain access to your papers. We have just finished the 7th annual issue, which is going to be published in January of 2022. The submission deadline for the 8th ECS issue is June of 2022. Should be noted that you have to receive or have received a PhD before submitting your paper. I am pleased to announce that Professor Combs is the 2nd annual JMR Early Career Scholar Prize awardee for his invited feature paper and review, Probing Surfaces and Interfaces in Complex Oxide Films via In Situ XPS or X-ray photoelectron spectroscopy, which was published in January of 2021. The honor comes with promotion of you, Dr. Combs, and your winning paper, as well as a cash prize of $1,000. Not bad. Your paper was chosen by the Associate Editors of JMR, Drs. Susmita Bose, Sarah Morgan, and Matthias Gherkin, and of course myself. It was the best paper out of the 23 published in the 6th annual issue. We were quite impressed with the quality of writing and your critical analysis of the related research. The review article will not only serve as a beautiful introduction for new graduate students in the field, but also a template on how to write a critical review. Ryan, please tell us a bit about your own journey and background and how you became a faculty member at Auburn University.
Well, Dr. Messing, thank you so much for the honor. I've worked on in situ, or what you might call in vacuo, X-ray photoelectron spectroscopy of oxide films since I started off as a postdoc at Pacific Northwest National Lab in 2013. I was working with Scott Chambers, who has been a pioneer in this area. And when I started as a postdoc, I knew almost nothing about XPS. I'd never taken any XPS data before, but their MBE system is connected to an XPS system, and it gets used every day. So I was there for 3 years as a postdoc, and then as I finished up and got an opportunity to build my lab here at Auburn starting in 2016, we've been working hard on all of this since we got our XPS system integrated with our MBE in 2018. So I was really honored to be invited to contribute to the article, and it was a real treat for my research group to dig in on all of this, because we were writing it at the height of the pandemic in spring of 2020 and during the lockdown into that summer when we submitted it. So that was something where we were all talking to each other on Zoom and discussing ideas for the review article. The recognition on the part of JMR and the Materials Research Society means a lot to me, because MRS is one of the leading societies for oxide film research, dating back decades now. I gave the first research talk of my graduate career at MRS fall meeting in Boston over a decade ago. It's also nice to be able to support JMR, I think, because there's been so many materials journals exploding in the field over the past 5 or 10 years, including a lot at for-profit publishers. I think it's really important to continue publishing in journals affiliated with professional societies as much as we can. So it was a real treat to get to write an open access review in the issue.
Well, thank you very much for that little plug there for JMR. We appreciate that. The paper was an excellent review about in situ XPS of metal thin films, their growth, and also there's a very nice section about properties and how they are correlated with your understanding of the growth process and what you learned during that. Certainly, this is extraordinary exciting times about thin films, and particularly their application in quantum applications. How does your paper augment that current body of research, and your own research for that matter?
Yeah, it's a great question. Quantum materials research is driving a ton of condensed matter physics and material science research right now. And I built my lab at Auburn sort of with that direction in mind. We were able to build the first lab in the US university with a hybrid oxide molecular beam epitaxy system connected to an XPS under vacuum transfer line. And when I was building my lab, I wanted to have the opportunity to look at materials that are particularly challenging to grow by conventional means, which is often the case for quantum materials. We're talking a lot of materials that are made up of these lower transition metal materials like niobium, tantalum, and hafnium, which are refractory. So that means that we use a metal organic precursor to deliver these elements instead, because you can't grow them by traditional MBE, because you're trying to evaporate metals that take 2,000 or 3,000 degrees Celsius to do that. So these materials are really exciting for future directions in the field as far as quantum materials go, but they're also really hard to make. That's where having an XPS connected to the system really accelerates our material development, because we can measure everything from film stoichiometry to chemical valence, band alignment, all of that within minutes after we've cooled our sample down from growth. And that's where having an XPS is really helpful to our growth process, because we can measure everything just from a contaminant to a cation charge state and feed that back into the next round of growth, often the same day. The other key point that we drive home regarding oxides, but it applies to, I think, pretty much all the materials we're looking at for quantum, in the quantum materials world, is surface stability. We talked in the article a lot about why assuming that the surface is stable can lead to flawed analysis and conclusions, which is something that you're really sensitive to when you're doing XPS measurements routinely. We're about to submit a paper right now on strontium niobate thin films grown by hybrid MBE, where we show how the surface is unstable using our XPS, and discuss ways to mitigate that using capping layers, something we discussed in the article as well. You find that these things get overlooked sometimes if you aren't doing a surface sensitive spectroscopy technique like XPS, which is why I think it's really such a powerful tool to improve your growth process and give you instant feedback for science as you're researching material synthesis.
Ryan, that was exciting. I'm glad to hear that you're already pushing the frontiers with your work on strontium niobate. That sounds very exciting. Look forward to seeing the announcements about that particular paper as well. Ryan, it was a real joy to meet you today. Certainly, I look forward to meeting you in person at a future MRS meeting. I hope that's soon, hopefully this fall in Boston. Thank you for contributing your outstanding work, though, at JMR. I will tell you that your paper is already extremely popular, as indicated by the number of downloads that we've seen already. It's trending very positively. Yes. We look forward to receiving more papers from you and your research group in the future. And we wish you all the best to yourself as well as your research group at Auburn University. Thank you so much.
Thank you.